So today, me, Leonid Pavlovsky, the product owner of our speech recognition platform, and Mateusz Kowalewski, our R&D engineer, will talk about speech recognition. What are the current opportunities, challenges, and solutions in this area? We'll cover a couple of practical examples and a couple of plans that we look into in the future that we look into. So let's start. Okay. Yeah, so that's us. You're gonna see these faces for around 30 to 40 next minutes. Feel free to ask your questions if you have any, like drop them in the chat, or just drop them in the chat as soon as we see those. We're gonna answer, and then in the end, we will also have a separate time for Q&A. So let's talk about, yes?
Sorry, Leo, but I don't think you share the screen unless
I'm not sharing the screen.
I can see it.
Okay, those were nice slides, just in case.
Yeah, now works.
Yeah, perfect. Okay, so those were nice slides. Let me show you the speakers, just in case. On the left, that's me speaking right now. And on the right, you're going to see Mateusz Kowalewski, who is our R&D engineer. And he's going to share a bit more about the technical solutions that we go through and that help us build a better speech recognition product. So what is the stage of speech recognition today? I mean, with generative AI, there are tons of cool opportunities for this area, right? Well, absolutely. Today's solutions are absolutely awesome. They work exceptionally well in well-controlled environments with more or less standard speech, especially with Gen AI that now helps us guess the words that are hard to recognize, because like with the combination with the large language models, it's now easier to make. But all of this is beautiful and great until you are a kid in a noisy classroom, and there are lots of other speakers in the background. There's a teacher yelling at someone or just giving instructions. There are other kids talking or completing their tasks. And also, remember, we're kids. We still learn how to talk, how to articulate certain words and phrases. Many of those words might be new to us. So there are unique pronunciation patterns, like 3 or tree, right? Those are going to be two different words, but might be mistakenly mispronounced, or three, flea, right? These sounds are typically mispronounced by kids. And what's even more important, because of these unique pronunciation patterns and educational environments, we don't always need to guess each single word that the kid is saying. Instead, we want to capture the speech as it is without guessing, because this way we can help kids learn, and teachers can see an unbiased picture on which parts of language and which patterns need to be worked with, like improved. And how exactly is this used? Well, there are early literacy assessments, oral reading assessments, several standard tests, and dyslexia screening. For example, dyslexia screening, like for those who haven't heard of dyslexia, this happens way more often than we know. So when kids have difficulties understanding certain symbols, reading words or understanding them, or even have an emotional reaction while reading words because it's challenging for them, then these are some of the signs of dyslexia. If the kids have certain patterns of misrecognition in words and symbols, these could also be signs of dyslexia. And capturing speech as it is really helps educators and teachers find out, well, are we making progress? Are we having like yellow flag, red flag? And it also helps to find out those flags early on. And also, all of those speech recognition solutions are awesome until you're a policeman amidst heavy traffic, trying to recording all of the conversations on an on-body cam without any special equipment or microphones. And amidst all of this work, you need to fill out the reports, and it takes a lot of time. And you need to stay in sync with the protocols and standards of behavior, which can also take time. So, and all time in these situations sometimes matters a lot, because sometimes it's also time to react to an emergency. One more challenge is in the healthcare industry, because it contains conversations between doctors and patients. Apart from the fact that they're extremely confident and that is sensitive data that has to be protected, there is a lot of specific terminology, and the weight of the accuracy that's required is very significant. There are also device limitations, because obviously there won't be any specific gear recording. And it also needs to, this speech recognition has to sync in with all of the reporting systems. But if that works, if that all works together, if we overcome these challenges, we let doctors do their work and spend more time with patients and less time with paperwork. So they are going to have the pre-filled reports. They're just going to have a look, refine if needed, and then focus on the patient or next patient. So we speak with a lot of customers and prospects, and we recognize this actually helps us recognize these challenges. And decide to go and research the speech recognition area in more details. And let's break down the challenges that we discussed and the solutions that we took to handle those. At this stage, I'm going to pass the word to Mateusz, who's going to be a bit more technical on these solutions.
Okay. Hello, everyone. So I will take over the technical part. So our main solution consists of three main building blocks. So we have advanced noise reduction, we have proper ASR that transcribes speech to text, and we have phoneme recognition from the said audio. We'll start with advanced noise reduction. So, well, why do we even bother doing this? And there is several reasons. So first of all, in real-life applications, there is noise everywhere. In the classroom, the noise comes from from other children, maybe from the teacher trying to scream over all the children. On the road, when there is policemen talking, the noise might come from the cars or from maybe some very heated situations, and there is a lot of very loud voices around us. So we really try to improve the speech clarity and to our solution to be as robust as possible in the noisy environment. And this noise cancellation, noise reduction really helps to enhance the quality of text and phoneme recognitions. Obviously, there are several challenges while doing this. So first of all, every situation is different, every noise is different. It's very hard to create one-size-fits-all kind of solutions. The noise is not really always, well, it's rarely stationary. It's rarely just on one amplitude or one frequency. It's very quickly changing. That's why trying to fit some standard simple solution might not really work too well. And we also don't really want to remove any necessary information, which is speech, because we want to remove just the noise and don't touch the speech at all, which isn't really that easy. And obviously we want to be computationally efficient, meaning we don't really want to slow down the application too much. So we've tested obviously several algorithms and settled down for the deep neural network. And we can change sort of how our denoising works based on the situation itself. So we can go with a standard approach. We can tune it a little bit just to fit each and every situation differently. Can I ask to move the slides, please, Leo? Thank you. All that speech, noise cancellation, is to enhance the text recognition. And text recognition translation really is what is the main part of the application, to take the audio and make it into the transcriptions. Along with transcription, we provide stuff like timestamps to know exactly in which millisecond the word was said, or some confidence score, which basically tells us how confident our solution is in saying that this word is actually the word predicted. When we come to challenges with text recognition, we obviously have noisy background that we sort of try to eliminate in the first step. Well, the speech, when we deal with children or maybe disabled people with troubles, because the speech might be distorted. It might not be very clear what the person is saying. And the last thing with modern neural networks that actually gives us trouble in some situations, for example, in what Leo described at the beginning in education, is that current solutions use context. So they look at what was said before the word that the network is predicting and what was said after the word that network is predicting, which isn't always good. We can imagine the case where the kid is learning how to count, and they count 1, 2, 3, 4, 5. So modern solutions, they will say, okay, there is 1, 2, then it's sort of similar, the 3 is sort of similar to 3. So modern neural network will input 3 instead of a 3, which isn't always good because, as I said, in education, we want to know that the kid made a mistake, so we can later on correct it. And this is where the phonemes comes in. But before that, I just wanted to say about our solution that we support several foundation models for the automatic speech recognition tasks, and we combine them with phonemes to get clearer view on the problem. Here on the bottom right, you can see the word error rate, which is essentially a measurement of how many words our solution got right compared to the percentage, obviously, compared to the reference text. And here, with separation and without separation, those are two variations of our network. One, no separation means without a noise cancelling step. With separation means with cancelling step. And Riva is a solution from NVIDIA that we benchmarked against. Riva ASR, obviously. And here you can see that when we use YouTube Kids, which is large data set of YouTube videos with kids speaking in it, and synthetic data that we generated, we can see that all the solutions perform really, really well. But when we use field samples from one of our partners, then we can see the huge difference between our solution with and without noise cancellation and with already made solution from NVIDIA. Can I go to phonemes, please, Leo? And now to phoneme recognition. So phonemes are the basic. If we think about text against phonemes, text is a representation of what we of the words of what we're trying to say. But phonemes are a representation of what we are actually saying, of the sounds. That's why when we try to do phoneme recognition tasks, we never fail as with ASR. We never fail in a case where the kid is saying 3 instead of 3, because even though the text is similar, the phonemes can be completely different. Obviously, here we also face several challenges like lack of data and even the state-of-the-art models that are available. They really struggled in the noisy environment. But we did it nonetheless, and it works, I would say, quite well. And this is sort of, this paired with text is core of our solution. It gives us the real overview of what is happening in the audio that we are running through our system. And can I have the next slide, please? Okay, I think that's, I will pass the voice back to Leo.
Yeah. So now I'm going to talk for a few slides about what happens after we have the phonemes, we have the timestamps, and we have the text transcribed. Because since we talk about the real world applications, we don't only need text. We need to do something with that text right away. And the faster we process it, the better, the business outcome is, and the better the outcome is for the end user. So speaking of educational environments, when we learn how to read, right, when we want to enhance our early literacy and analyze things, how do we, like, we have the teachers who are obviously skilled in doing that. However, how can we use our technology to make this learning process even more objective, even more detailed? Because if you have like 20 kids in the room and like tracking the timer, like the way the reading assessments were at school, right? So we had the teacher, we had the timer, and we had to read the passage and see how much time it's going to take, and then see how much we are able to read within that time. However, so the main metric when it comes to assessing the reading is like, it's the North Star of oral reading assessment. It's words correct per minute. So how many words were read correctly per minute? And measuring this manually can be quite challenging because you have to set the timer in time, like at the right moment. You have to count how many words were read correctly. You need to see what were the errors, right? And stop it, and then replicate this process for 20 more kids, one by one. But what if there are other structures within it? So there are different units of analysis. We can analyze a particular sound pronunciation, how certain words are pronounced, phrases, sentences, paragraphs, and text. Even if those phrases, sentences, or words don't typically go next to each other, we still can keep the accuracy thanks to the combination of the foundation model, the phoneme recognition, the timestamps. All of this is made possible. So scoring is something that we build on top of that. But what if we go further? How does the teacher has to objectively track the amount of hesitations, repetitions, self-corrections? That's a lot of work, right? And then if we have this accuracy, like, so fluency is how fast you speak, how many errors you make, and accuracy is more about how many mistakes you make. So the mistakes are also different. And if we see that the kid tends to, for example, have more pronunciation errors than misreads or substitutions. Or if the kid reads everything correctly or skips words sometimes, we need to flag it in time, and it's going to be much easier to correct it and have the faster learning curve. There are actually more research on that, and if you are interested, you can visit these links that go into a deeper research into unbiased like scoring of oral reading assessments. Now I'm going to pass the word back to Mateusz, and we're going to talk about what happens in more complex situations where the transcribed text needs to be aligned with certain regulations and rules of behavior, right, or different forms. And we're going to circle back to some of the use cases that we started discussing in the beginning. Mateusz, over to you.
Currently, we are working on another track, which is adding LLM at the end of LLM with argument generation at the end of our transcription. So we can imagine a case where a police officer is talking on the busy road, and we've already acquired the transcription from our system, but then we need to pre-process it even further. So we can ask, okay, LLM, we can ask from the transcription, tell us what did the officer behave correctly in this situation, or maybe what the situation was about. Does this situation come under standard traffic check of, I don't know, sobriety, or is it something with maybe related to road violence? And so with that, we can extract as many information with as little human need as possible. And this is something that is easily scalable also for other industries. Especially, we have a case, for example, for healthcare, where there is a lot of time being spent by the doctor to fill in all the forms. After all the talking with the patient, the doctor has to fill all the notes, what are the symptoms, what drugs did he prescribe, so on and so forth. And here the process can be easily automatic. And this really reduces the costs and increase the speed of and the capacity of the doctor. And here we can also listen to one of the samples from the real life situation.
WPQ 813 disturbance hotshot 12501 Tech Ridge Boulevard. Supervisor clear.
Edward 804.
Edward 804.
Can you clear our call 3? We can hear the disturbance at the hotshot next to us. Can you put us on that call?
10-4. Edward 807. Same traffic for you as well. For that disturbance hotshot, it's going to be 12501 Tech Ridge, Building 22, apartment. Gate code. Neighbors are arguing. Comp can hear glass shattering. Male versus female. Been going on at least the last 10 minutes. The female was screaming for help. The male was yelling. Possible intox or drugs. They're going to be on the 2nd floor.
7, we're getting signs of disturbance at apartment. We'll be kicking at the door.
10-4. All units hold the air.
Shots fired, shots fired.
Shot.
As you can hear, the audio quality is really bad, especially the police officer who's talking through the walkie-talkie. And this is exactly where our solution can shine and can reduce the reaction time and help speed up all the processes. I think I will pass the voice back to Leo.
WPQ 813 disturbance.
So while doing this, we also need to remember that these models take a lot of compute. And especially if not particularly optimized. And also, speaking of the real world scenarios that we discussed today, but there are actually many, many more of those. But what's common between all of them is that they all are very confidential. You don't want to use any of that data for modal improvement, right? You don't want to send it to, like, you want to send it elsewhere. You don't want to do that, right? You want to keep it on your security infrastructure. So a solution like this has to be like cloud agnostic. It has to be hosted solution. So you want to be able to host it on premise, and you still want to spend less time integrating it. So it has to be available on something like AWS Marketplace. By the way, this solution is coming on AWS Marketplace soon. So yeah, if you're using it, then welcome to have a look. Speaking of big names, we also are partnering with NVIDIA to use their stack. Mateusz, is there anything that you want to share about the NVIDIA stack?
So we are also using adding support for the NVIDIA stack. We can support their ASR and their preprocessing and their phoneme recognition models in our application. Also, we are in the talks of with NVIDIA to be added to the NIM and deployed using Riva. That is essentially all for now from NVIDIA side.
And probably back to me regarding the pricing. So basically, depending on the stage where certain business is, or the stage of implementation or plans, different options might work. And that might be either like trial, where you want to see whether it works for you and whether you need time to implement it, or you want to have the time to do the gradual rollout and use the annual subscription, or even own the solution forever. All of these are possible. But if you don't want to, like if customers don't want to commit to a longer period right away, they can pay as they go. So the more they use, the lower the price per hour of transcript is going to be. And also, what if they don't have to use some of the features? Then they can also benefit from the consumption-based model. And for service companies like SoftServe, that is a new way to engage with customers and a way to offer them something that they probably have been missing for years, right? And wanted to have for years. That's just a bit more flexibility. But I think it's time to stop talking too much about that and have a look at how the demo works. It's now available on our GenAI portal, and you can request this demo. And it's coming on AWS Marketplace, and it's coming to our R&D talk right now. And I'm gonna switch the screen. I'm gonna give it to Mateusz so that we can run the demo. Like right here, right now. So
can you turn off the screen sharing?
Oh yeah.
Thank you. So is my screen visible, just to confirm?
Yeah, I can see it.
Okay. So here is our platform, speech recognition platform. we can select the sample or use one of the pre-recorded samples. Also record something on our own. For the reference text, to double check if our platform is making a correct prediction, here we can input it. I just started with some beginning of what we are about to hear. We can drag and drop or choose one of the samples from our own computer and click transcribe audio. As you can see, we obtain text transcriptions. At the beginning, I would like for all of you to listen to the audio.
Yay! I won! Okay, take this game away, please. Thank you. All right, that was round one. Are you ready for round two?
I am. This one I'm going to win.
Okay.
So I can see, as you can hear, the audio isn't really easy. There is a noise in the background. There is a kid screaming on top of her lungs. But here we make prediction. We make transcription, and each of those has its own start and end timestamp, so we can see exactly when the word was said, as well as phonemes. They also have start and end timestamp. And we also share some statistics that we can export later on. So here I just inserted yay, I won, so first 3 words. So we just have 9% really accuracy. So we miss about 29 words. There are also other various statistics based on timestamps and on the words. You can check our platform under the link that Leo shared with you. And I believe that's all from me.
Let me switch back to the presentation where we are, and we're actually going to the end. So that was about 30 to 40 minutes as we agreed. But the point right now is right about time to ask questions if you have any. Let's see if we got any questions. Let me check the chat. I don't see any, by the way. You can always reach out to us. If you're watching this in the recording, and I know that majority of people are going to watch this in the recording, which is totally fine, feel free to drop an email to rndcom@softserve.com, and we'll be happy to answer. And my last message here today is just to, when you speak, you want to be heard. So yeah, let us human beings be heard and understood.